Welcome back to Miss B Makes It Easier, and we're moving right along with this graph. And it says a student investigated the relationship between the electrical potential difference across a device and the current flowing through that device. The results were recorded in table 1. So here we have potential difference, and the units are volts, and here we have current, and the units of current is amperes. Okay, now if you look at the parameters, you would see that potential difference runs from 0 to 45, while current runs from 0 to 0.6. So therefore, potential difference has a wider parameter than current. Now it says here, plot a graph of potential difference B versus current I. So therefore, potential difference is what we're judging. So that's the Y. We're judging it while we change the current, which is our X. Anything that you judge goes on the Y-axis, and anything that you keep changing to judge something goes on the X. So this is our dependent variable, and this is our independent variable. Okay, so let's start plotting. So this potential difference goes on the Y. So let's start labeling. So this is our potential difference. And this is our V. And then we have our current. We have, remember, our current is current. We have amperes. Okay. So we're going from 0 to 0.6. Let me see. 0.1, 2, 3, 4, 5, 6. Okay. Let's do that. So 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. So please remember that this and these numbers are smaller than these numbers. Okay? All right, and now for potential difference, let's just make a scale of, we could go in fives. We can go in fives. So if you look here, how many do we have? We could go in fives. So let me see. 5, 10, 15, 20, 25, 30, 30. No, so we go 5, 10, 15, 20, 25, 30, 35, 40, 45. Makes sense. It's a wider scale with 10. So we're going in increments of 5 every 10 spaces. So 5, 10, 15, 20, 25, 30, 35, 40, 45. And oh, let's keep it as 1 decimal place. So because that's what they have. So let's keep it at 1 decimal place. And is it the same for down here? Oh, so we're going to keep it at 2 decimal places for our x-axis. Great. So now what we're going to do is draw the lines for our axes. So we have here, draw a line. Oops, it went off. That's me getting a little excited. Now that happens to the best of us. And then you can go up here and pretty much, guys, my desk is filled with paper. Okay, so we draw our line here. Great. So you should have your stuff. Put your 0. Okay, so we're going to start plotting. So every 2 spaces must be 1. And how we know that? So we're going to divide. And we're going to say from 0, we say 5 minus 0 is going to give us back 5 divided by the 10 spaces between here. So divided by 10. So each space is half, is 0.5. So if you keep adding 0.5, if this is 0.5 and you add 0.5 again, then this will be 1.0. And if you add, this will be 1.5, then 2. 2.5, then 3. 3.5, then 4. 4.5, then 5. Just keep adding 0.5, okay? So let's go. It says when the potential difference is 1.5, which is the third point, then the current is 0.02. So this is 0.1. You want to know what one of the points between here is. So you can say 0.1, and we said 0.1 because 0.1 minus 0 is equal to 0.1. It shows up there, divided by the 10 spaces in here. So each of these spaces is 0.01. So this would be 0.02 and so forth, right? So you just keep adding 0.01. So when the potential difference is 0.5, which is here, this point here, so I mean it's 1.5, sorry. Then we look for 0.2, that's the current here. So 0.2, great. And we're moving along. When the potential difference is 4, which would be, so let's do it at current. When the current is 0.05, which should be here, then it will be, the potential difference will be 4. So this is 2, 2.53, 3.54, okay? When the current is 0.15, which should be here, because this will be 0.11, 0.12, 0.13, 0.14, 0.15, the potential difference is 10. Okay? When the current is 0.24, which should be here because this is 0.25. So when it is 0.24, it will be 18. So we're going up. For this is 15, 16, 17, 18. And then when the current is 0.4, it's 30. So that's easy to find because those are obvious points. And then when the current is 0.6, the voltage is 45. Awesome. So it looks like we have a straight line graph or maybe a best fit line. I don't know until I plot. So it says calculate the gradient of the line obtained in A. Do not use any point that coincides with a point from the table. So we can't use any of these points up here. And that's what I would be telling, that's what I've been telling you all the time. So let's draw our best fit line or straight line. So here we have our points. Let me just keep it like this because I think you can see it good here. So it looks like all of the points fall on this line. Great. You don't have to find the best fit. Right. So now we could find 2 points, any 2 points on the line. And I'm going to use this point right here. Remember this is not to use any of the points. Don't coincide. I'm going to use this point right here. Okay, and so this is my first point. I have y1 and x1. So this would be 50 volts, 50.0 volts. And so x now would be, if you come down, if I come down here, my x would be this point right here. And I might as well just draw my perforated line one time. because remember you have to show your triangle. And so if this is 0.6 right here, then, and this is 0.65, this is 0.66, 0.67. So 0.67 amps. And now for this one, this is my second point, so I'll say Y2 is equal to 0.5, right? 0.5 volts. And my X2 is equal to 0.01. And it's a good thing I worked these out earlier so I wouldn't have to be wondering. And so now to calculate, you just say the slope and so let me bring across my line. Bring across my line, right across here. Perforated line. Right. Now we can work out the gradient, and it's good because it encompasses all of the points. So you say gradient or the slope is equal to delta y over delta x, which is rise over run. I'm going to say y1 minus y2 over x1 minus x2. Fill in my numbers easily, just look for them on the graph. So you say 50.0 volts minus y2, which is 0.5 volts, divided by x1 is 0.67 amps minus 0.01 amps. And note that I have my units in there. Don't stop putting in your units. You need to keep your units there. And then we're going to calculate one time. So you use your brackets. 50 minus 0.5 divided by 0.67 minus 0.01. And you end up with 75 volts per amperes. Or you could write it as 75 volts per ampere. It's the same thing. Do you see that? Great. So this is our graph. If I bring this up a little bit, you can see it. Oh boy. You see it? It's there. All right, so I hope this helps, and I hope you got the same gradient that I did. All right, so have a good night, folks. See you later.